Hi everyone, welcome to the fourth session of our online tutorials in chemistry for class 12. I hope and pray that all of you are keeping well at home and that you are able to follow and keep up with whatever is being taught through these online tutorials. I also have had my share of hiccups in trying to overcome my fear standing here in front of the camera and trying to teach you, and also trying to incorporate my teaching in this new system. But remember, no matter what obstacles we face, whatever problems we have in front of us, there is nothing that we cannot overcome if we only try. So whether it's in your studies or in your daily life, remember that if you try, you can always overcome your problems. So keep on trying and trying until you overcome your problems. Now today, we will look up a new unit from inorganic part. In the previous 3 sessions, we have seen about solutions, and that was from physical part. Today, we will look up a unit from inorganic part, that is unit 6, and it is about general principles and processes of isolation of elements. Now, I want you to try to remember whatever you have learned about the reactivity series of metals in your class 10 science. Reactivity series of metal, it is a series of metals in which they are arranged in order of their decreasing reactivities. I hope you remember that. So if we see that series, the reactive metals, the most reactive metals are found at the top of the series, and those which are less reactive, they are found at the bottom of the series. So from there, we understand that there are some metals which are very highly reactive, whereas there are those which are very less reactive. Now, those metals which are very less reactive, they will not react easily with other elements, and therefore inside the Earth's crust these metals will be found in the free or uncombined state. The free or uncombined state of a metal, it is called as the native state of the metal. So metals like silver or gold, platinum, this being very less reactive, they are found in native form or native state in nature. Whereas there are those metals which are very highly reactive, and therefore they combine easily with other elements. And these metals therefore will be found in the combined state, not in the free state. They will be found in the combined state. Usually they will be found in the form of carbonates or chlorides or sulfates, sulfides, or in the form of different halides. Now, all these compounds of a metal which are found inside the Earth's crust and can be obtained by mining are called as minerals of the metal. But there will be only some minerals from which the metal can be extracted profitably and conveniently. Only those will be called as ores of the metal. So we can say all ores are minerals, but all minerals are not ores. Let us see an example here. In the case of iron, iron can be found in the form of carbonates. It can be found in the form of different oxides like ferrous oxide or ferric oxide. It can be found in the form of sulfate or in the form of hydroxide. It can be found in the form of chlorides or iodides. All these are compounds of iron which are found inside the Earth's crust. So all of these compounds are called as minerals of iron. But iron can be extracted in a convenient and profitable way from only some of them, and only those will be called as ores of iron. For example, ferric oxide, which is also called as hematite, it is the main ore of iron. Likewise, for aluminum also we have the main ore, bauxite, which is aluminum oxide. For zinc also we have different minerals, but we have just one main ore from which zinc can be extracted easily, and that is zinc sulfide. So for each metal, there will be some minerals from which it can be extracted conveniently and profitably, and only those will be called as ores of the metal. Now, the process that is involved in the extraction of a metal from its ore is called as metallurgy. So metallurgy refers to the entire scientific and technological process involved in the extraction of a metal from its ore. Now, there are three major steps that are involved in this metallurgy. Let us see which steps are involved. What are the major steps involved in metallurgy? The first step is called concentration. Then we have the second step, which is called as isolation of the metal. Then we have the third step, which is called as refining. Concentration means removing the impurities from the ore. Once the ore has been purified by removing the impurities, we go for isolation of the metal. That means extracting the metal from the ore, and after extracting the metal from the ore, we go for refining, which is just purifying the metal. So these are the three major steps that are involved in metallurgy. Let us see in detail about these three steps. Concentration, as I said, is the process of removing impurities from the ore. Since the ore is taken out from inside the Earth's crust, it will be mixed with various types of impurities from inside the Earth. The earthy or rocky materials or impurities that are present along with the ore are called as gangue or matrix. So concentration simply means removing these gangue or matrix from the ore, or purifying the ore. Concentration of an ore can be done by different methods. Depending on the nature of the ore, concentration can be done by different methods. So let us look at some of the important methods that are used for concentration of ores. The first method that we have for concentration of the ore is hydraulic washing. Hydraulic washing simply refers to washing by water. Now, this can be done if the ore particles are heavy and the impurities are light. We just put the powdered ore along with the impurities on a slanting table, which is called as a well-filled table. This slanting table has grooves and riffles on the surface. The powdered ore along with the impurities is put on this table, and then it is washed with an upward stream of water. The lighter ore particles, they will be washed away by the water, whereas the heavier ore particles will remain on the table. That is how the ore gets separated from the impurities, and the process is called as hydraulic washing. The second method that we have for concentration of ore is magnetic separation. Magnetic separation, it is based on differences in magnetic properties between the ore and the impurities. Either the ore should be magnetic and the impurities non-magnetic, or the impurities should be magnetic and the ore should be non-magnetic. In this method, the ore along with the impurities, they are put on a conveyor belt which moves around a magnetic roller. We have the magnetic roller here, which helps this belt to move. The powdered ore along with the impurities are put on this belt, and then they are allowed to move. Suppose the ore particles are magnetic, the impurities are non-magnetic. As they move along, the ore particles being magnetic, they will be attracted by this magnet, and therefore, as they pass through, they will be attracted by the magnet and they will fall near the magnet. But the impurities, since they are non-magnetic, they will not be attracted, and therefore the momentum will carry them away from the magnet and they will be thrown away, or they will fall at a further distance from this magnet. And that is how the magnetic ores are separated from the non-magnetic impurities. The third method we have for concentration of ores is called as froth flotation process. Now, this froth flotation process, it is used for concentration of sulfide ores. And it is based on the principle that sulfide ores, they are weighted by oil, but they are not weighted by water, whereas the impurities are weighted by water, but not weighted by oil. In other words, the sulfide ores, they mix with oil, whereas the impurities do not mix with oil. Now, if you just take water and oil, try to mix them together, you will find that the oil does not mix with the water. You will always find that the oil comes to the surface. It comes to the top, water will go down to the bottom. So we find two separate layers. If we have a mixture of water and oil, we will find the oil coming to the surface, whereas water will be at the bottom like this. Sulfide ores, since they are weighted by oil, if we put a mixture of sulfide ores along with impurities into this mixture of water and oil, the oil will go up to the top carrying the sulfide ores, since they are weighted by the oil. The impurities, since they are not weighted by oil, they will not go to the surface. They will remain in the water. This is basically what is done in this froth flotation process. In actual practice, the powdered sulfide ore along with the impurities, they are put into a vessel containing water and some oil, like pine oil or some fatty acids are used to mix with water here. Then we put some substances which are called as froth stabilizers. This can be either cresol or aniline. Now, this mixture is agitated with the help of some rotating pedals, which not only agitates the mixture, but also allows air to go into the mixture. Due to this, froth will be formed. Some bubbles of the oil will be formed, which rises to the top. And these oil particles will carry the sulfide ores along with them to the top, and this will form the froth on the surface of the water. The impurities, since they do not mix with the oil, they will be left behind. In the solution here, they will be in the water, remain in the water. This fruit can be skimmed off, and then it is allowed to subside to finally obtain the pure or concentrated ore. Now, in this case, the oil that we use, it can be either pine oil or some fatty acids. These oils, they act as collectors. The function of these collectors in this process is to increase the non-wettability of the ore in the water and to collect the ore particles from the mixture. Substances like cresol or aniline, which are also put into the mixture here, they act as froth stabilizers. And as the name suggests, they stabilize the froth. In certain cases, we use some other substances which are called as depressants. These are used when we want to suppress some compounds or substances from going into the froth. Suppose we want a particular substance, we want to prevent it from going into the froth. In such cases, we use depressants. And these depressants can be also used to separate sulfide ores from each other. For example, if we have an ore containing lead sulfide as well as zinc sulfide, we want to separate this sulfide ores, the two sulfides from each other. In this case, we put sodium cyanide as a depressant. This sodium cyanide, it effectively prevents this zinc sulfide from going into the froth. So only lead sulfide goes into the froth and it can be separated from the zinc sulfide. Then finally, we have the fourth method of concentration of ores, which is called as leaching. Leaching, it is a chemical method for separation, for concentration of ores. In this leaching, the ore is dissolved in a certain solvent, a suitable solvent. A solution is formed, and from that solution, the ore is again retrieved back, leaving the impurities behind in the solution. For example, the oxide of aluminum, bauxite ore, which is the main ore of aluminum, it can be purified by this leaching process. Let us see how bauxite ore is concentrated by the leaching process. The ore, the bauxite ore, which is basically aluminum oxide, it is treated with sodium hydroxide. The aluminum oxide, it is converted to sodium aluminate. The sodium aluminate that is formed, it is neutralized by passing carbon dioxide gas when aluminum oxide, hydrated aluminum oxide is formed. At this state, a little amount of freshly prepared aluminum hydroxide or hydrated aluminum oxide is put into this solution in order to initiate the precipitation. After this aluminum oxide is formed, this is filtered off, it is dried and then heated to finally give aluminum oxide in the pure form. So when we treat the bauxite ore, aluminum oxide, with sodium hydroxide, it gets converted to sodium aluminate. And on passing carbon dioxide gas, we get hydrated aluminum oxide. Adding a little amount of freshly prepared hydrated aluminum oxide initiates the precipitation. That means this hydrated aluminum hydroxide gets precipitated, which is filtered off, dried, and then heated to give pure aluminum oxide, which is now called as alumina. So, leaching, then hydraulic washing, then magnetic separation, and froth flotation process. These are the 4 methods that are used for concentration of different types of ores, depending on the nature of the ore. Once the ore is concentrated, that means after all the impurities have been removed from the ore, we go for the next step, that is isolation of metal. In this step, we obtain the metal from the ore. Now, in this step, actually there are 2 sub-steps that are involved. The first sub-step is called as conversion to oxide. And the second sub-step is called as reduction of the oxide ore. After we have obtained the pure metal, first we convert the ore into an oxide, especially if it is in the form of some carbonates or hydroxides or sulfides, we convert the ore into oxide form. Now, conversion of the ore to oxide can be done by 2 processes. Roasting and calcination. Roasting means heating the ore strongly in excess of air or in the presence of oxygen. Calcination means heating the ore in very limited or in absence of air, very limited supply of air or in absence of air. During both processes, the volatile impurities are removed, and during roasting, sulfide ores are converted into oxide ores. During calcination, carbonate ores or hydroxide ores are converted again into oxide ores. So if we have carbonate or hydroxide ores, we go for calcination. There, the carbonates or hydroxides are converted to oxides. If we have a sulfide ore, we go for roasting. And here, also the sulfide ore gets converted into oxide. Once the ore has been converted into an oxide, we go for reduction of the oxide ore. So for reduction of the oxide ore also, we have different methods depending on the reactivity of the metal. For those metals which are less reactive, which are not very reactive, their oxide ores can be easily reduced by using carbon as a reducing agent. For example, if we have zinc oxide, we can use carbon as a reducing agent to reduce this zinc oxide to zinc. Carbon monoxide will be given out as a byproduct, and zinc metal will be given out. That means the oxide ore is reduced to the metal. The zinc oxide is reduced to zinc. Now, in place of carbon, we can use some other more reactive metals also, like aluminum. For example, if we have chromium oxide cannot be reduced easily by carbon. So in this case, we use aluminum as a reducing agent. So the metal oxide is reduced to give the metal. And in this case, as I said, aluminum acts as the reducing agent. So if the metals are not so reactive, we can use some other more reactive metals, or even carbon or carbon dioxide or carbon monoxide to reduce the oxides. However, if the metal is very highly reactive, then its oxide cannot be reduced by other metals. And therefore, in such cases, we go for electrolytic reduction. If we use carbon as a reducing agent, this process is called as smelting. Smelting means reduction of an oxide ore by carbon. The process in which aluminum is used as a reducing agent, it is called as the aluminothermite process. Now, if we cannot use smelting or the aluminothermite process for reducing the oxide ore, we go for electrolytic reduction. Now, in this electrolytic reduction, the ore in its molten state, it is electrolyzed in an electrolytic tank using some suitable electrodes. Now, if this is the anode, and this forms the cathode, the metal gets deposited at the cathode here during electrolysis. For example, oxide of aluminum is reduced by this electrolytic reduction method. That means to obtain aluminum from its oxide, we use this electrolytic reduction method. Aluminum oxide, it is electrolyzed in an iron tank lined with carbon. Now, this lining of carbon, it acts as the cathode, and we have a series of rods of carbon or graphite which are joined together and act as the anode. The ore, that is aluminum oxide, it is mixed with some cryolite as well as calcium fluoride, and this forms the electrolytic solution. Now, on passing current, aluminum metal gets deposited at the cathode, and at the anode, either carbon dioxide or carbon monoxide or even both of them will be formed at the anode. So basing on the nature of the metal, we can use any of these methods for reducing the oxide to give the metal. But no matter what method we apply for obtaining the metal from its ore, the metal that is obtained is usually in its crude form. Crude form means it is not in the pure form. There are still some impurities mixed along with the metal. So after we have isolated the metal from its ore, we go for the last step, that is refining of the metal. refining or purification of the metal. So in this step, we remove all the impurities that are present along with the metal to obtain the pure metal. So once again, refining can also be done by different methods. There are a number of methods that are used for refining of metals. Let us discuss two very important methods that are used for refining metals. The first one is electrolytic refining. In electrolytic refining, the impure metal is made the anode, and a very thin piece of the pure metal is made the cathode. A salt solution of the same metal is used as the electrolyte. For example, if we want to purify copper metal, then the impure copper will be made the anode, and a very thin strip of pure copper will be made the cathode. Anode means this is connected to the positive terminal of the source of current, which may be a cell or a battery, and the cathode is connected to the negative terminal of the battery or the cell. So suppose we have copper, impure copper, which we want to purify. We use a very thin piece of copper as the cathode again, and we use a salt solution of copper, such as copper sulfate, making up the electrolyte. On passing current, copper gets oxidized at the anode. Oxidation takes place at the anode. So at anode, copper gets oxidized. That means it loses electrons. Whereas at the cathode, copper ions from the solution, they gain electrons, they get reduced, and copper metal will be formed. And this gets deposited at the cathode. So by and by, as the reaction proceeds, the anode becomes thinner and thinner because copper metal from here goes into the solution after getting oxidized. Whereas the cathode gets thicker and thicker because copper metal is being deposited here. The impurities that were present along with the copper metal here will come down to the bottom and settle down as anode mud. Only the pure copper metal gets deposited at the cathode. The second method is called as vapor phase refining. In this vapor phase refining, the metal is first converted into a volatile intermediate compound, which is then further decomposed to give back the pure metal. For example, in Mond's process, nickel, it is converted to nickel carbonyl, which is then heated at a higher temperature to give back the pure metal. So as the process takes place, the impurities are left behind in the solution, and we obtain the pure metal. So there are other methods that are also used for refining of metals. Please look them up in your book. And in our syllabus, there are 4 metals whose extraction we have to study. That is extraction of aluminum, extraction of copper, zinc, and then iron. To study these extractions, you just need to identify which method is used for concentration, which is used for reduction, and which is used for refining. If you can remember these different methods that are used, then you can easily learn, and you would be able to find out how or what are the different steps that are involved in the extraction of these different metals from their ores. In the next class, we will look up another new unit from our organic chemistry part. So till then, study well, and take care. Thank you so much.